Hi everyone, this is Mrs. Ligon and we're going to give this video notes thing a try so you guys don't have to miss out on a lot of instruction while I'm not in the building. So we're going to take a look at our next lesson, which is going to be kind of a callback to the stuff that we did last week. I hope you all had a great weekend and you're ready to learn. So we're going to talk about what's the big deal with degrees and radians. Remember that degree measurement was defined by taking a complete revolution and dividing it into 360 even increments. Those increments are what we call degrees. We can divide degrees into 60 equal increments called minutes and divide those into 60 more equal increments called seconds. But we're not going to be talking about the minutes and seconds too much today. On the other hand, we learned about the radian measure, and that's defined by wrapping a number line around the unit circle. Remember that distance was 2 pi. This assigns every real number to an angle that subtends the arc on the unit circle, thereby creating a one-to-one relationship between the set of angles and the set of real numbers. Another advantage of using radians, which are real numbers, is the ability to graph the pairs in a coordinate plane. So let's talk about this and answer the questions lower down on your page. Do radians measure length or angles? Let's think about that. The 2 pi is referring to the distance if we were to travel around the whole outside of our circle. For measuring distance, we're going to be talking more about length. Angles are what we're measuring when we use degrees. The next question, what is the relationship between 1 radian and a radius? Let's go back and take a look at our unit circle. So it was 2 pi, the entire circumference of our unit circle. What's the equation for the unit circle's circumference again? We know the radius equals 1 unit, and we know the equation for circumference is c equals 2 pi times our radius. So we're going to rewrite that. We have 2 pi times the radius. And we're going to replace that radius with 1 unit. And we get that 2 pi, the total number of radians in the circle, is equal to our circumference. So 1, the unit of our radius, is going to be equal to 1 radian as we're traveling around the circle. Oops, sorry. Our next question, how many radians does it take to intercept the entire circle exactly once? So when we're intercepting the circle, we're cutting it in half. So if we know that 1 radian equals the radius, we know that the radius goes from the center of the circle to the outside of the edge of the circle. So let's take a look at that. Here's our circle, here's our center point, and that line indicates the radius of the circle. If we're intercepting the circle exactly once, we're going to draw from one end through the center to the other end. That is our diameter. The diameter is twice the radius, or 2r. So it takes 2 radians to intercept the entire circle once. This next question is all you guys. I want to know why you think mathematicians often use radians rather than degrees to measure angles. So go ahead and write that down. Okay, our next question is what degree measure between 0 degrees and 360 degrees is equivalent to negative 600 degrees? So what does the negative mean? If you remember from our last lesson, we know that negative means that we're going clockwise around the circle instead of counterclockwise. So we're going to go all the way around our circle, starting at our initiation point. Then we're going to go around the circle. Oops, I went counterclockwise, but in this case, for 360 degrees, my mistake doesn't make a huge difference. So now we're going to go the rest of the way clockwise around the circle, starting again at that initiation point. When we go clockwise, we need to figure out how much further we need to go. So 600 degrees minus 360 that we've already gone is going to give us 240 degrees. So let's go 240 degrees clockwise around the circle. Each quarter of the circle is 90 degrees. So once we've gone halfway around the circle, we'll have gone 180. Now we just need to go 60 degrees more. And that would be right here. So 240 degrees, we still have how many degrees going counterclockwise to make it the rest of the way around the circle? So we have the 90 degrees of that quarter, plus another 30 of this little sliver. So 90 plus 30 equals 120 degrees. So negative 600 degrees around the circle is going to be 120 degrees if we just move counterclockwise. That was a little confusing, but I promise we'll practice that more tomorrow when I come back. Now we're going to do some stuff we've worked on before. We're going to convert 165 degrees to radians. First, let's convert it to revolutions. Remember, to convert to revolutions, we're going to do 165 divided by 360. Now we simplify that fraction. We can divide 165 and 360 by 5, and we're going to get 33 over 72. That fraction can be simplified further, giving us 11 over 24. So 165 degrees is 11/24 of a revolution. Now we're going to have to multiply that revolution by 2 pi to give us our measure in radians. 11 times 2 is 22, so we have 22 pi over 24. And again, we're going to simplify this fraction to 11 pi over 12. So 165 degrees is 11 pi over 12 radians. We can simplify this whole process further by figuring out a ratio to convert our degrees to radians. If you can see, we divided by 360 and multiplied by 2 pi. So we're going to turn that into a fraction itself. 2 pi is going to be our numerator, and 360 is going to be our denominator. So now when we want to go degrees to radians, all we have to do is multiply the degrees by 2 pi over 360. So what are we going to do if we want to do radians to degrees? We're going to do the inverse. That's going to be 360 over 2 pi. That's what we're doing here in this next problem. We have 5/6 pi's that we need to convert into radians. So we're going to do 5 pi over 6 times 360 over 2 pi. We can cancel out things that occur in both our numerator and our denominator when we do this multiplication. Like pi occurs in the numerator and denominator, so it will cancel out. We can do 360 divided by 6 to simplify that as well. So 360 divided by 6 is 60. So we're going to have 5 times 60 over 2. 5 times 60 equals 300. So we're going to have 300 over 2. And 300 divided by 2 is 150. So 5/6 pi equals 150 degrees. Turn over to the back of your worksheet now. The radian measure of an angle is equal to the length of an intercepted arc in the unit circle. So let's find the intercepted arc of our unit circle when the angle is 45 degrees. That's going to be this arc here that I'm going to highlight in red. There it is. So now we're going to use our conversion to figure out what 45 degrees is in radians. So 45 times 2 pi over 360. 45 times 2 is 90, so we have 90 pi over 360. We can simplify 90 and 360 by dividing both of them by 90. And we're going to get pi over 4. So 45 degrees equals pi over 4 in radians. We're going to use this same process to finish filling out our table down here on the worksheet. So I want to convert 30 degrees into radians. I'm going to do 30 times 2 pi over 360. Thirty times 2 equals 60, so we have 60 pi over 360. 60 and 360 can both be divided by 60. We get pi over 6. Now we're going to do the opposite to convert pi over 4 radians into degrees. So we're going to do times 360 over 2 pi. We're going to cancel out the pi's that occur in the numerator and the denominator. So we're going to do 360 in the numerator and then 2 times 4 in the denominator, which is 8. We're going to simplify these by dividing the numerator and the denominator both by 8. And we're going to get 45 degrees. I would like you now to finish the rest of this table on your worksheet. You can work together. Please remain on task while you're going through and finishing this. I'm going to leave the sheet like this so you can copy down any notes you may have missed.